So this video is on double replacement reactions. It's when you have two compounds reacting together and you make two different compounds. When you have this, although it does look like you're making the same thing, you're actually not. They're making two different compounds. So we're going to go through this just like we have in the past by looking at the question, and then I'm going to write the metals in blue and the non-metals in red. So firstly, the question might be something like this. Potassium sulfide reacts with aluminum nitrate. So potassium, I would look at my periodic table of ions, is positive. Sulfide is S2 negative, so that when they come together, I get K2S. And that I'm adding it to aluminum, which is Al3 positive, and nitrate, which is NO3 negative, so that when they come together I get Al and then bracket NO3 bracket with a 3 down here. So in terms of who's dancing with who, it's kind of like two couples dancing. So here's one couple and here's another couple. The couple is made out of a metal and a non-metal and a metal and a non-metal. So the two blue ones can't go together and the two red ones can't go together. So the blue one is going to switch partners and go with the other red one. So the metal is going to go with the non-metal. So I would always go back to the drawing board and say, okay, potassium is positive, and now it's going to go with nitrate, which is NO3 negative. I would look these things up on the periodic table again just to make sure that that is correct. And so that when I put them together, I see that I get this, which in words would be potassium nitrate. Okay, and then the other thing that I'm going to make is I'm going to make aluminum, which is 3 positive, and it's going to go with sulfide, which is 2 negative. So I'm going to get this. Now remember that all of this stuff down here is like scrap paper. I shouldn't see any of that stuff. So that should be just for my figuring out what the compound is going to be. And now I'm going to try and balance the compound. It might be better to do this like this and do it as NO3 groups. Rather than separate it into nitrogen and oxygen. So counting wise, I have 2 potassiums on the reactant side. I have 1 sulfur. This means I have 1 aluminum. I have 1 NO3 group. Over here I have 1 potassium, 3 sulfurs, 2 aluminums, and 1 NO3 group. So we need to make them the same. And I'm just kind of looking at it all. So let's start with the aluminum. So starting with the aluminum, I see that there's a 2 here, and there's a 1 over here. So I'm going to put a 2 in front of here to make this 2, but this also changes this to 6. Okay? And then in order to make this be 6, I'm going to put a 6 in front of here, right? Because then this makes 6 NO3 groups. But it also changes this to 6. So that means I'm going to have to change this one to 6. So in order to get 6 potassium, I'm going to have to put a 3 in front of here. So that makes that 6. Now this means I have 3 sulfurs over here. Oh, and look at that. I have 3 sulfurs over here and 2 aluminums. So now it is balanced. Okay, next one. So the next one is another type of double replacement. So it's iron 3 chloride reacts with silver sulfate. So first thing is we're going to, you might want to pause it and see how far you can get all by yourself and then see if you get the same answer as me. So first I would, on my scrap paper, of course, look up what iron is. Iron 3, remember that as soon as I see the Roman numeral, that tells me the charge of it. And now it's going to react with chlorine, right? So that means that I'm going to get Fe and then Cl3. And then I'm going to have silver, strong color. Silver is Ag, silver is positive, and sulfate. Notice the ending is ATE. That's a weird ending, so I should be looking on the polyatomic for it. So I see that I have then Ag, this 2 is going to come down here, so I'm going to get a 2, and then SO4. Okay, now as far as dance partners, so we have one metal and non-metal group and one metal and non-metal group, so they're going to switch dance partners. So that means that iron is now going to go with sulfate, right? So go back to the drawing board and say, okay, it was iron 3, and now it's going to go with sulfate, which is 2 negative. Make sure that you look these things up, right? Like make sure that you look up what sulfate is 2 negative. The other thing is we've talked about this before in single replacement, but if it was iron 3 over here, it has to remain iron 3 over here. It can't change to a different charge of iron. So now the formula for it will be Fe, this 2 is going to come down here, and we're going to have SO4, it has to be in brackets with a 3. Okay, and then the other couple that we're going to have is we're going to have Ag, and if you have to do it on your scrap paper, go ahead and do that, right? Ag, and it's going to go with Cl negative. So that would just be AgCl, like so. So don't bring like the 2 over here to over here, for instance, and don't bring like the 3 from the chlorine over here, over here. The only way that those subscripts come into play is by like when you put the compound together. Now, the only way that I can make it balance is by by writing coefficients in the front. So I'm going to write coefficients in the front of the compound. It might be a good idea to look at the SO4 as a group instead of like individuals. Just erasing my scrap paper so that you can see again that you shouldn't have any positives or negatives on your compounds, right? They have a 0 net charge. The other thing I want to make note of is that, do you guys notice that the metal is always written first and the non-metal is always written second? So the metal always has to be first in the compound and then the non-metal is second. So you shouldn't have like a red and then a blue. That is a no-no. In terms of, does it matter if I wrote iron 3 sulfate here first compared to silver chloride first? No, it doesn't matter. Like I could switch these around and that's still exactly the same thing as long as you have both of those compounds there and all the subscripts and so on. Okay, so let's try and balance it. Okay, so just looking at this, I feel like we should go with the SO4 groups first. So there is 3 SO4 groups. So I'm going to put a 3 in front of here. That also changes this now. So I have 3 times 2, so that is 6 silvers. So in order to get 6 silvers over here, I'm going to put a 6 in front of here. That changes the chlorine to 6 as well. So now I'm going to have to put a 2 in front of here, which gives me the 6 chlorines, right? But now I need also 2 irons, and look at that, SO4s. Oops, I didn't write the list the same. So now I can see that it's SO4 is 3 and 3, silver is 6 and 6, chlorine is 6 and 6, and iron is 2. So we're good. So it's balanced. Okay, next one I wrote out the compounds for you, and then you can see if you can figure it out. You would still have to know that this copper is the metal, right? Aluminum is the metal. So I can figure out that copper is going to go with chlorine. And that aluminum is going to go with the sulfate. So the aluminum with the sulfate is no big deal, right? Because the 3 is going to go here, the 2 is going to go here. Now, as far as the copper goes, I have to figure out what kind of copper is over here first before I can do this part of it correctly. So when I look at this, there's kind of like, it's like a puzzle and you kind of have to work backwards. It can either be copper 2 with SO4 2 negative, or it could be copper 1 with SO4 2 negative. And sometimes you might like have to actually write this out and like ask yourself, okay, is it copper 1 or is it copper 2? So if it was copper 2, do you notice that this is 2 positive, this is 2 negative, so that they would cancel each other off. So you would get CuSO4, which does not match that formula that I have there, right? So that means that it can't be copper 2. But if I had copper 1, I would actually get this formula that was there. So that means that it is copper 1, which means that this one also has to be copper 1. So that when they go together, you get this. Now, often I see that people have written like a little 2 down here. I'm not sure where the 2 came from. Either that they think it's copper 2 because copper 2 is like the most commonly occurring one. But if you can tell which kind of copper it is, you need to use that copper, right? You can't just assume that it's the most commonly occurring one. If you can tell what kind it is over here, you need to use that, and it needs to maintain itself, right? It can't just magically change into something else. Okay, and now in terms of balancing, let's see if we can get it to balance. I'm going to also say that if you cannot get it to balance, the problem is probably that you missed either a little subscript somewhere, so you missed like putting the 3 here, the 2 here, or so on, or that you have maybe mixed up the couples, so maybe you don't have the right couples going together, or switching dance partners. So those are things to look for. Okay, so there's 2 coppers on the reactant side, there's 1 SO4 group, there's 1 aluminum, and there's 3 chlorines. There is 1 copper over here, there is 1 chlorine over here, there is 3 SO4s and 2 aluminums. So in terms of getting it to balance, I think I'm going to start with the sulfates again. So here is 3 and here is 1. So I'm going to put a 3 in front of here. Okay, that does change this one to 3, but it also changes my copper to 6 now. I need the copper to be 6 over here then, so I'm going to put a 6 in front of here, which changes this also to 6, so it changes the chlorine to 6. Okay, now I have 6 chlorines over here and I only have 3 over here, so that means I'm probably going to have to put a 2 in front of here because 2 times 3 gives me the 6. And I have 2 aluminums now, which actually all balances out, so now it's good. Okay, 2 more questions to go. Okay, so when I look at this, this is actually an acid here. The reason I can tell it's an acid is because there's hydrogen in the front. There would also be this little AQ behind it. Remember that that's standard for aqueous, right? That's like telling you that it's acid. Usually things that have hydroxide in them, especially like barium hydroxide, that's an example of a base. So this reaction can actually be called double replacement because it is still 2 compounds reacting together. But remember that when you have an acid and a base react together, that can also be called a neutralization reaction. And so the things that you produce then are water and a salt. So this can be an example of a double replacement, or it can be an example of a neutralization reaction. So both of them work for in terms of classifying the reaction. It works exactly the same way though as any other double replacement. So you have some metals. So I'm going to rewrite it in the color so that I can see it. And I have some non-metals. And they're reacting together, so I'm going to have to figure out who goes with who. So firstly, I can go this way. Hydrogen is going to go with hydroxide. Because it is a product, you can either write it this way or you could write it this way, whichever way you wanted is okay with me. Only when it is acting as a reactant do we need to write it out like that. The other thing that we're going to get is we're going to get barium phosphate, so I might have to use my scrap paper and say, okay, barium is 2 positive, phosphate is 3 negative, so that when they go together, I get Ba3 and PO4 2. Okay, and now this one's kind of tough to balance because I could look at the PO4 separately and I could look at the barium separately, but then how do I look at the hydrogens? Do I look at them as hydrogens or do I look at them as hydroxides? So I'm going to show you that usually if you balance like the weird things, this sounds kind of interesting, but if you balance the weird things first, usually the hydrogen and the hydroxide, or the oxygen, sorry, balance themselves out. So we're going to try that. So let's just look at the bariums. I have 1 and I have 1 phosphate group. And over here I have 3 and I have 2 phosphate groups. Okay, so let's try and just get that stuff to balance. So let's go first with the phosphate. So if I need to have 2 of them, I'm going to put a 2 in front of here. Okay, and then let's get the bariums to balance out. So I need 3, so I'm going to put a 3 in front of here. Now let's count the hydrogens on this side, and then we can kind of figure out how many oxygens we should put over here. So I have 6 hydrogens because I have 6 here. And then I have 2 times this, so I got 2 hydrogens here, and then times it by 3, so I got 6 more hydrogens. So that is 12 hydrogens. Okay, in order for me to get 12 hydrogens here, I would have to put a 6 in front, right? Because 6 times this one would give me 6, and then 6 times this one would give me 6. So I would get the 12 hydrogens in total. So you should see now that it is actually balanced out. You could go through and count the oxygen also if you wanted to, but it will be balanced also. Okay, one more. Okay, this is a great one to do because lots of times people see hydrosulfuric acid and they, I don't know, sometimes they just like bypass the word hydro in here, and they write like H2SO4. This is sulfuric acid, and it is not hydrosulfuric acid, so make sure that you actually have hydrosulfuric acid. If something was hydro and ic acid, that means that it had to be a hydrogen and something that ends in "ide." So it's actually hydrogen and sulfide that come together to make hydrosulfuric acid. So it's H2S. And how I know it's H2S is because hydrogen is positive, sulfur is 2 negative, right? So I get that formula from there. And then it's reacting with aluminum hydroxide. So aluminum is Al3 positive and hydroxide is OH negative. Now it is super common for me to see this like that. I want to show you and point out that this is a lot different than this. Because if I asked you in this one on the bottom, how many oxygens are here, there's 3 oxygens, right? If I asked you how many oxygens are in here, there's only 1 oxygen. So here, even just the brackets themselves make a huge difference. So the brackets actually should be here. So make sure that you do have the brackets. I'm not sure what it is about the hydroxide molecule, but for some reason people tend to leave the brackets off with hydroxide, so make sure that you are kind of aware of that and looking out for that. Okay, so now hydrogen is going to go with hydroxide. So again, like back to the drawing board, say hydrogen is positive, hydroxide is negative. So I'm going to get water, right, or HOH if you want to. And then I am going to get aluminum, and aluminum is going to go with sulfur. So I'm going to get Al2 and S3. Okay, and then let's try and balance it out. I'm just kind of looking at it first to see if I could balance it in my head. So we have H, S, Al, and O, H, S, Al, and O. Okay, so counting on the product side, I have 2 aluminums, I have 3 sulfurs, I have 2 hydrogens, and 1 oxygen. On the reactant side, I have 2 aluminums, 1 sulfur, 2 hydrogens, how about? 1 sulfur, 1 aluminum, and I don't actually have 2 hydrogens because I have 2 here, and I have 3 in here, so I actually have about 5 hydrogens, and I have 3 oxygens. Okay, so now let's just check my counting again. Yeah, okay, and so now we're going to get it to balance out. So I think I might start by doing the sulfur. So I see that there is 3 sulfurs here. So I'm going to put a 3 in front of here. Okay, that changes the sulfur to 3. Before I go and count the aluminums, I'm going to try and do the aluminum to balance first. So I see that there's 2 aluminums over here. So I'm going to put a 2 in front of here so that that changes that. Now I'm going to count how many hydrogens I have on the reactant side. So I have 6 hydrogens here. Then I have 3 times 2, so I have 6 more hydrogens, so I have 12 hydrogens in total. So that means that I'm going to have to put a 6 in front of here, right? That will give me the 12 hydrogens that I need. And let's just see if the oxygens work themselves out then, because now I have 6 oxygens here. And look at this, I got 3 times 2 is 6 oxygens over here. So it worked itself out. Okay, for now, I also don't want you to worry about things like when it says solid aluminum hydroxide. That means that like behind this we would have an S, right, indicating that it's a solid. We're going to talk about solubility in one of our first units, and so we'll talk about how we get these, what they're called is phases on the ends of the compounds. But for now, I'm just worried about, can you write out the reaction? Can you figure out who goes with who or who dances with who, and can you get it balanced? Okay, the next video will be like a mixture of all of them and seeing if you can kind of pick out the reactions just by looking at them. Can you remember all 5 types of reactions? Could you tell me what a formation reaction is? Can you tell me what a double replacement reaction is? And so on.